Hello students, Ganesh Patil here. I am going to talk about data structures and algorithms and problem solving course which I'll be teaching you. First of all, let me introduce myself. I am Ganesh Patil. I have around 9 years of experience. I have graduated from IIT Madras from Computer Science Department, and after graduating I worked with Intel, VMware, Amazon, and currently I am working with Microsoft as a software developer. So teaching is my passion. I like teaching a lot. If I were not a software engineer, I would have definitely been a teacher somewhere. So I have got Outstanding Teaching Assistance Award 5 times in a row at IIT Madras. I have also taught in GATE Academy for Theory of Computation, Computer Networks, and Operating System subjects. I have also taught in online mode with various academies for DSL Go and problem solving courses, and students have loved those courses. So this is my philosophy, how we can understand any concept better. Okay, so first of all, there would be some problem, and to solve that problem we invent or introduce something. Okay, that answers our why question, like why a particular thing was invented or introduced. Now, what are the functionalities, what are the specifications that particular thing can provide, and how it is used practically? If we know the answers to these three questions, we can understand the concept better. So in this course, I'll be teaching about why a data structure was invented, like what were the problems for the previous data structures, and why a particular data structure was introduced, what are the functionalities, what are the specifications, and how it is used practically. So all the things we will be learning in detail for each and every data structures. So again, let's start with the basic. Why do we want to learn data structures and algorithms? See, if we want to build any building, it has to have a strong foundation. So data structures and algorithm is nothing but the foundation. So those are actually basic building blocks in the software industry. And we can say if our foundation is strong, we can build on top of it. So survival in product based companies will be much easier. Your career growth will be very good. And another thing is it's a pathway to the product based companies. Okay, so all the product based companies actually hire you based on your DSL Go and problem solving skills. Why? Because they want to check the your mental ability. Can you solve a particular problem using some data structures? Okay, and how you can approach to the problem. So they analyze your mental capability in terms of DS and algos, and if you can actually solve those problems, if you can apply your knowledge to the problems, then you will be hired. And obviously product based companies provide better work life balance, better work quality. You can have a bigger impact if you work in product based companies, and obviously they provide higher packages, so it is definitely better to work with product based companies. So we will begin with the basics. We will use Java programming language as the programming mode. Actually, in the interviews, you can use any programming language, but majorly we will focus on Java because 90% of the projects in your industry are actually based on the Java language. So we will start with Java language. We will understand the basics. For example, if this is the statement integer a is equal to 13. So what does that indicate? This is actually the data type. Data type is the type of the data which it can hold. So in memory, there will be a block which is going to store the integer value. The name for that memory block is A, and value inside that block is 13. This is what this statement means. Now, the problem is, let's say if I have to store like 100 students marks, let's say. Okay, uh, so is it possible that we can take like a1, a2, a3 up to a 100 times. No, it will be quite inefficient to manage all those things. So that's why we came up with the arrays. So using arrays, we can store all those 100 elements just in one statement. So I'll be teaching you how you can build the existing knowledge and you can write the another data structure. So for example, in arrays, if we let's note down the previous thing as it is, integer a is equal to 13. Now if I want to convert this into array, because array is like multiple elements stored at one contiguous locations. Okay, these are like 100 elements. So 13, 14, let's say 20, 25, all those are elements. So if we use these square brackets here, it indicates the array. It's a collection of integer values. Now how can we assign the values here? In the curly braces, if we write all those values, we get the array of 100 elements. So now you can access each and every element by using the index. So this is how a of I indicates the index number. This is how we can access each and every element. This was the one-dimensional array. So it's a one-dimensional array. Now if I add another dimension to it, so now let's say this is only x. If I add another dimension, which is y, it becomes a 2D matrix. So lot of interviewers actually focus on arrays. They do ask the 1D or 2D array problems. All those important interview problems we will be studying in our course. And like we should also learn what are the practical applications of the any data structure. So for example, if we use our phone, our contact library is actually arrays. Then in arrays are used in most of the online booking things, the card and many other things. The arrays are used practically. Moving on, we will be studying about the strings. There are practical applications like in your email box, spam detection algorithms. They work on the strings data structures. Plagiarism checks, spell checker, all those are the applications which use strings as the data structures. Moving on to stack and queues, we actually come across stack and queues everywhere in our day-to-day life. This is how we can understand stack and queues better. If we have multiple plates, we generally rack them on top of each other. So now this is called as the stack. Now if I want to remove a plate, I can't directly go to the bottom and remove this plate, because it will be difficult to remove this plate. All other plates might fall, might break, and your hand cannot reach to the last one. So that is what stack is. So in stack, we do have elements placed on top of each other. Now this fashion is called as the last in first out. The element which is inserted at the last is taken out first. So last in first out is the stack data structure. Now talking about queues, if we go to some bank, then all the customers do stand in the queue, and whoever is standing in the front gets the chance to get served. So that structure is called as the FIFO, first in first out. The one who enters first will be exiting first. So that is the queue data structure. There are a lot of practical applications again. If we know our telephone, like mobile, there will be notifications, right? All those notifications use stack, because the latest notification will be on the top. Those are the practical applications of stack. We'll be also focusing on searching and sorting, very important topic in DS algos. Searching is like finding something from a pool of data, that is called as the searching. So let's say you have array of numbers, and if you want to search, so that is called as the searching algorithm. So if the data is unorganized, searching is difficult. If the data is organized, for example here, the data is organized into the ascending order. Now applying some algorithm called as the binary search algorithm, we can efficiently search a number. Okay, talking about sorting, if we want to arrange numbers in a particular format, for example descending or ascending order or descending order, like if we want to arrange all these numbers in descending manner, it will be 40, 30, 20 and 10. So this is called as the sorting. So there are inefficient algorithms and efficient algorithms for sorting, like efficient algorithms like quick sort, merge sort. We will be studying all those algorithms along with their complexity analysis and why they are better. Now, all the while we have seen the primitive data type and arrays which can hold multiple values. Now, what is the problem with the arrays? Let's say I have 1 lakh elements. Then all those 1 lakh elements have to be inserted only at one location. All are consecutive in location. So will it be possible to always get 1 lakh elements of space in main memory? No, it might not be possible. Also, if my application demands to delete certain things frequently, then arrays become inefficient. In arrays, you have to declare a size upfront. All those were the limitations of the arrays. So that's why people came up with the linked lists. In linked lists, let's say this section is stored at independent location. This section will be stored somewhere in memory independently. This will be stored independently somewhere. But now there has to be linking between all these, right? So that's why we have the pointers, which will direct us from one element to the another element. If I want to store a pointer in my data structure, it has to have a different field. So that's why this is called as the node, and this will have, let's say, a primitive data type integer some value, and it will also have a pointer which will be pointing to the same type of node, because this is pointing to a node only. So this is how linked list node will look like. There are several benefits of using linked lists. We don't have to store all the elements at one place. We don't have to upfront declare the length of the linked list. For example, if there is event and we are not sure how many people are going to come to the event, then it will be a waste of memory, waste of resources if we use arrays. Instead of that, if we use linked lists, as and when guests are coming, we can fill the information and we can store that in the memory. So this is how linked list will solve the problem of all the disadvantages of the arrays. So there are two types of linked list: singly linked list, where only a single node which points to the next node, and there are doubly linked list. In doubly linked list, there will be two pointers. One will point us to the next one, and the previous pointer will point us to the previous node. That's why this is called as the doubly linked list. So obviously there will be two fields which will store the pointers. So we'll be studying all these linked list concepts as well along with the problems. And if you talk about the practical applications, if you open some browser and if you open an URL and then you move to the second URL, then you move to the third URL. Now you can see there are two buttons which get highlighted: front button and back button. So all these URLs are actually stored as a doubly linked list nodes. Let's say URL2 is stored here, URL3 is stored in another node. Now when we use front and back buttons, the current pointer will be moving across this doubly linked list. So that's the practical application, quite handy when we work on the browser implementations. Moving on, now the linked list were like this, where you could go only in one direction. Either you can go front or you can go back if it is doubly linked list. But what if your application demands certain conditions? For example, if this happens, then you should do this. If this doesn't happen, then you should do this. This is called as the branching. Most of the ML algorithms use branching. Now this is not possible with linked lists. So that's why we need to use trees. So this is the binary trees. Bi means 2. So here every node will have maximum of 2 children, the 2 outgoing pointers. So this is how binary tree looks like. This is the sample binary tree where each node might have maximum of 2 children. And binary search trees is a special type of binary trees where the data has certain properties. So the data value which is stored here will be, sorry, I'm getting a call. The value at this of this node will be higher than this but lesser than this. That is called as the binary search tree. So in your computer, if you see the file explorer where you have the folder structures like one folder inside another, then there could be multiple folders. This uses a generic tree data structure, and most of the algorithms in machine learning use the branching techniques. They use the trees concepts. Moving on, we will study graphs, very important problems if you are aiming for top-notch product-based companies. Concepts are very important, very practical. If you know Facebook, LinkedIn, all those social media platforms, they will have graphs used inside them. For example, a user creates a post. Now this post is liked by another user. Some another user can comment on it. So all these things are done using graphs data structure. Talking about LinkedIn, whenever we send a connection request to someone, immediately it shows all the people which you might know. Now this happens because we have added this as connection. Now all the people to whom this guy is connected, we are actually too distance from him. So it will also suggest that you might know few of these people. So that is the graph implementation. In graphs, we use BFS and DFS traversal techniques. This is breadth first search and DFS stands for depth first search. In breadth first search, we cover the breadth from the current node. So all the adjacent nodes are finished first and then we move to the next nodes. In depth first search, we select a node, we select one of its adjacent nodes and then we go to one of its adjacent nodes. So this is how we go deeper into the levels. So we will study BFS, DFS. One of the popular problem on graphs is number of island problem. So if matrix is given which has 1 and 0 values, we have to find out how many islands are there. So that is one of the important problem. Data structures is incomplete without talking about hash map and hash sets. So hash map is a special data structure which has storage like keys and values. So searching on keys is very efficient, it's very fast, so that's why we use hash maps. Now hash sets, if we collect all those keys and we store in some data structure, so that we can just find out if that particular key exists in that data structure or not, we use hash sets for that. We will study all these. Most of the problems use a hash map or hash sets, so that we can solve the problems in a efficient manner. Now talking about tries, tries is the dictionary data structure. In Google, if you search something, it will show you the auto suggestions. If we type one word, it will complete the other sentence, the next sentence. So that is called as the auto suggestion. So all those auto suggestions are implemented using tries, or we can call them as dictionaries. Now very important part for interviews and for DSLGO problem solving is the complexity analysis. Now let's understand what is complexity analysis. Let's say for solving some particular problem, one person comes with one algorithm, another person comes with another algorithm. Now how we can say which algorithm is better? So one way is we can take one computer, we can feed this algorithm on a particular problem set, and we can find out how much time it has taken to execute and how much space or main memory it took while it executed the algorithm. Same way, we can take the algorithm too on the same machine and the same problem set, and we will measure how much time it took and how much space it consumed. Now whichever consumes less time and less space, we will call that algorithm as the efficient algorithm. So will it be possible always to take the algorithm, take it on the same machine and find out? Why on the same machine? Because different machines can have different processing powers, different memory, so it might vary a bit. So that's why I am talking about the same machine. So is it possible always? No. And also just by looking at it, we cannot know. We will have to execute it somewhere, and then we will have to find out which is better. So in order to solve this, scientists came up with the complexity analysis. So in complexity analysis, we find out which is better in terms of time and space just by looking at the algorithm. Now I will tell you some very good tricks by which complexity analysis will be a cakewalk for you. Let's say it's an array of n elements. If we have one for loop in our program which traverses n time, the complexity will be order of n. Let's say I write another for loop which is nested into this. Since it is also going on n elements, this is also going on n elements, so the complexity will be order of n into n, which is order of n squared. So I'll be teaching you the techniques. Just by looking at the code, you will be able to find out the time and space complexities. Along with this, I'll be sharing a lot of resources which are helpful for your interviews, like uh, all the important YouTube videos, important interview experiences, all those I'll be sharing. Nowadays, there are a lot of good posts on LinkedIn which tell us how to study, from where to study, what kind of questions you can expect in the interviews. All those things we can get from the LinkedIn posts. So I'll be sharing all those LinkedIn posts with you. I'll be giving a lot of practice questions which you can practice. I have curated a list of 50 most important problems. So when I recently gave the Amazon interview, all the 4 questions were out of these 50 questions. I also have a list with 150 questions, 200 questions, and 450 questions. So based on your convenience, based on the time you have, you can prepare from this list. This will, like I assure you, most of the interview problems will be out of these lists only. I'll be also teaching you how you can practice on various platforms like Lead Code, Geeks for Geeks, how to make best of them. I'll be teaching all of that. So I hope to see you guys in my course, and I'll be pretty excited for you guys to take you to the product based companies. Thank you.